It was the week before winter break, and Andrew was buried under a mountain of exams, assignments, and last-minute projects. On top of all this, the physics teacher assigned a new project about writing problems with forces in motion, and he was stumped on what to do. Andrew stared at his notebook, tapped his pencil against the wall, and sighed in annoyance. Feeling frustrated, tired, and defeated, Andrew crumpled his paper into a small and perfectly round ball and threw it across the room, 3 meters in total, at his trash can. If he were to make this shot, it might renew his motivation to finish the project, and he knew there was a lot on the line here. Andrew's hand and the top of the trash can were both 1 meter above the floor. The paper ball left his hand with a speed of 5 meters per second at an angle of 49 degrees from the horizontal. Because of how strong he was, he compressed the ball such that the force of air resistance on the surface of the ball was negligible. Would it land in the trash can? The question hung in the air as the ball flew. Once the paper ball left his hand, gravity was the only force acting on it. The free body diagram shows a dot representing the ball, with a single downward arrow labeled as the force of gravity. Because there was no horizontal force, the ball's horizontal motion remained constant, unaffected by any forces. The ball's velocity can be thought of as two separate components, horizontal and vertical. Horizontally, it traveled about 3.3 meters per second. Vertically, it moved at roughly 3.8 meters per second. Gravity acted only on the vertical motion, pulling the ball downward and creating a curved trajectory through the air. After about 0.91 seconds, the ball fell past the vertical height of the trash can, and it was clear it wasn't going in. Andrew's aim was off, and he certainly wasn't motivated to continue his project. The ball landed short, only about 2.5 meters to the trash can, and coincidentally, in his dog's water bowl. The ball floated in the center of the bowl, completely submerged. The ball's radius was 1 centimeter. The next question arose naturally. How much does the floating paper ball weigh? In the water, the ball experienced two forces. One was the upward buoyant force from the water, and the other was the downward force of gravity acting on its mass. The free body diagram shows these forces balanced, keeping the ball suspended in the water's grasp. The volume of the paper ball was calculated using the formula for a sphere. V is equal to 4/3 pi r cubed, which was about equal to 4.19 times 10 to the negative 6th cubic meters. Multiplying this volume by the density of water and gravity gave the buoyant force, which was equal to the ball's weight, or the force of gravity. Solving for the mass, the paper ball weighed approximately 0.0042 kilograms, or 4.2 grams. Andrew missed the trash can, closed his notebook, and went to sleep. He then proceeded to fail the final and wondered why he'd ever take this class. Also, thank goodness he quit basketball.